Well, I want to finally move on to the next major category of streams. So we spent a lot of time talking about byte streams. Well, I also want to talk about the reader classes. So just a quick overview on the reader class. We'll do an introduction and look at the class declaration and look at the subclasses and look at its fields and its constructors, its methods, some sample code, and some differences between the reader and the input stream. So just a quick introduction here is that the reader in Java is an abstract class that reads characters from files. So in simple words, the reader class reads character streams and not byte streams. Is the superclass of all reader subclasses. And so the concrete class that extends the reader class operates on Unicode character streams. So instead of byte streams, these are designed as effectively text streams. So just a quick look at the class declaration. So the reader stream class extends object, right? Because it itself is kind of like the mother of all readers. Just like the input stream was the mother of all the byte streams, this is effectively the mother of all character streams in terms of input character streams. And so it's going to implement the closable, the auto closable, and the readable interfaces. In fact, one thing you're probably going to notice with the reader character stream is that it's going to have a lot of the same calls as the input stream for the byte stream. So the general syntax to declare, it just makes reading characters easier and more intuitive. So the general syntax to declare the reader stream class in Java is as follows. It's an abstract class, right? So it's really designed to be subclassed by the other concrete reader classes, but then all those subclasses can be of data type reader. It can have a member to reader. It extends object, and so it's going to implement readable and closable, the two very critical interfaces that have methods that define what we do with input streams effectively. So the most important concrete subclass of the reader class is the input stream reader. It contains an underlining input stream from which it reads input in bytes, and then it does the conversion from bytes to Unicode characters according to an encoding, a specified encoding that you give. So it has a default encoding, but you can even select alternative encodings as well. So super powerful class for reading text. So in addition to the input stream reader class inside of our java.io package, the same package we've been looking at all the other classes with, it also contains several reader classes that read characters without directly requiring an underlining input stream. So these are all the classes that we'll look at. And notice that a lot of these look very similar to what we were looking at before if you just replace reader with input stream. So we have a file reader, we have a buffered reader, we have a car array reader, we have a string reader, we have a piped reader, we have a filter reader, we have a pushback reader, we have a URL reader, we have a line number reader. So we're not going to look at all of these. We'll look at some of them that are similar to input stream just so we can see how similar they are. And so you'll know in the future whether you need to use an input stream or a reader based off of whether you're working with characters or working with bytes. And again, I think that's one of the advantages of kind of stepping through this with the rigor we are, is that when you start looking at all these classes now, you won't be overwhelmed and not understand what's happening in IO. You kind of understand the two major separations between readers and writers and input streams and output streams, and that each concrete class has a set of additional features based off of what your criteria are. So these concrete subclasses of reader have very similar functionalities as the input stream subclasses, except input streams use bytes as their fundamental unit of information, while the reader streams use characters. And so that is where an input stream reads a byte, the reader reads a character, which is why they wanted to differentiate using the terms readers and writers. Okay, so the reader actually does have a field. So the reader class in Java defines the following field that has protected access. It's of data type object, and its label is lock. And just know that it's used to synchronize operations on the stream, because it's always important that when one thing is reading or writing, that it's locked so nothing else can read and write on it simultaneously. That way you can always ensure that the state is consistent and stable. Okay, let's look at some of the constructors of for Reader. So remember, Reader is an abstract class, but it does have two different constructors. So Reader class is defined with two protected constructors. It's protected because it's designed to be subclass, and so the subclasses can overload these. It does not define any additional public constructor, so it has a protected constructor, and this will just create this will be the default one, right? This is would create a new character stream reader whose critical section will synchronize on the reader itself. And then you have a reader constructor that you can pass in an object that represents your lock. And so this constructor constructs a new character stream reader whose critical section will synchronize on the given object you give it. So you can lock it to that object. Okay, so the reader method defines the following methods in Java, all of which are public. All these methods are identical to the methods available in the InputStream class. So the most important reader class methods are as follows. So a lot of these are going to look similar, and that's by design, right? And some of them might not be similar. So let's take a look at the list. Well, a close. Very consistently, we always want to close our streams when we're done either writing or reading from them. So this method closes the stream and releases any system resources associated with it. We have a mark where we can pass in an int value that allows us to mark the present position in our stream. We can also have the mark supported, that's the test, where we can query our stream to see if it supports mark operations, and it returns true if it does, false if it doesn't. That if it supports mark, then it also supports the reset method as well. We have null reader. So this method returns a new reader that reads no characters. We have a read method. This method reads a single character. So again, this will read a character for us as opposed to a byte. We have the ability to read and pass in a character array. So this method returns an array of characters with data, and it returns an int value that represents the number of characters that were read. And if the reader stream has reached the end, then it'll return back the value of -1 to indicate that the array is not modified, that there's nothing more to read. There's an abstract method for read. So these others, except for close, have not been abstract, but this read is abstract, where we can pass in a character array and then give a number of characters and a offset position. And this will work just like the previous reads, where it will read that number of characters starting from that position from the character array. And again, it can return -1 if the reader stream reached the end. We also have a read where we can pass in a car buffer data type. So this read method was added in Java 5, and it directly reads characters into the specified character buffer starting at the buffer's current position. And so it returns the number of characters read, or -1, if it's at the end of the stream. We have a ready method. So the ready method returns true if the reader stream is ready to be read, or false if it isn't. So, and we'll take a look at that method in one of the samples. We have a reset method. And again, this is like with mark, the reset resets the reader stream by moving back to the earlier position. We have the ability to skip using some long integer to skip past a number of characters in the input stream. And so it returns the number of characters actually skipped, or -1 if we're at the end of the stream. And then also we have a method that allows us to transfer to, and then we would pass in a writer. So a writer is like an output stream, but for characters. So when we see a writer data type, that's what that's referring to. So the transfer to method reads all characters from this reader and then writes those characters to the specified writer in the same order that they were read. And so all the methods defined in the Java reader class, except for mark supported, will throw an IO exception on error conditions. Okay, let's take a look at some examples of this. Okay, let me jump up here. And so let's go into IntelliJ. I prefer to be able to run our code. Oh, no, not there. Okay, so here we go. So let's go to our reader tester right here. And so to test reader, we'll actually have to use a concrete class. So here I'm going to import the abstract class reader, but I can't directly instantiate it. So I'll also go ahead and import a file reader, which is a subclass. It's a concrete class that will go ahead and extend reader. I'm also going to import IO exception, and I'll just have my main method throw the IO exception so I can focus on the code itself. But again, normally you'd want to nest all of this code in between try catch block. Here, what I'm going to do is I'm going to create a new file reader, but I'm going to save it as a reader data type so that we can really examine the method calls that a reader has that all readers have access to. So here I'm going to read from the reader. Now notice when I read, I'm still returning back an integer, but I'm returning back an integer that can be encoded as a full character. So, and then what I'm going to do is, so long as the data that I'm reading from my reader, from my character input stream, isn't a -1, which represents the end of the stream, then I'm going to cast that integer into a character. I'm going to print it out, and actually let me go ahead and run this now. And we see, welcome to Java programming. And so let me actually go to my file.txt. So here, so inside of this my file.txt says, welcome to Java programming. So when I create my file reader here, I'm loading this file. I'm reading the first character from it. I'm checking if the first character isn't 1. So I have a value. So I'm going to say, is it -1 or not? If it's not, I'm going to print it out, which I do. It's the first one is W. Then I'm going to read the next character, and I'm going to continue this while loop until I hit a -1. And so I'm effectively going to print to my console then the entire characters that are inside my file.txt. And then I'm going to print a new line, and then I'm going to does my file.txt support mark operation, mark supported, and no, it does not. And just the default reader doesn't do that. If you want mark supported, you'd have to use an actual concrete class version of it. And yep, that is. And so some differences between reader and input stream, right? Because this is the big distinction we're making, right? Between input streams and readers, between character streams and byte streams. So the reader reads sequences of characters, where input stream reads sequences of bytes. The reader class defines a read where we can pass in character byte arrays, whereas our input streams would normally take in byte arrays for the read methods. Our reader class does not define an available method. It defines a Boolean ready method, which we will look at in one of our future samples. And the reader defines an int read, where we can pass in that char buffer method for reaching characters from a character buffer. Excellent. And so that's at least our initial examination into reader, which works on character streams as opposed to input streams. And so If there's no questions, these slides now, since they're very similar to the ones we've already looked at, are going to be much, much shorter. We're going to spend much less time because it's just a lot of repetition. We're just changing what effectively we're reading and writing in terms of the unit away from bytes into characters. So again, if you're doing text, you use readers and writers. If you're using data, you're using input streams and output streams. Effectively is how you want to think about that.